As promised, Year 12s, this is going to be a review of our chronic and acute adaptations test. So question 1, oxygen deficit. Looking for an answer. The process of exercise, where there is process during exercise where there's not enough oxygen in your bloodstream to work at a steady state. Therefore, you're more reliant on that lactic acid system. Obla occurs for an extended period, causing fatigue in the earlier parts of this exercise. So that's what you needed there for 1 mark. Best definition for your VO2 max. I've got the body's maximum capability to utilise oxygen with glycogen as its main fuel source. So the beep test assesses your body's ability to consistently increase your aerobic intensity until you pass your lactate threshold. And then 3 is B. So the myoglobin content of our muscles. What that does is it looks at the rate of diffusion of oxygen from blood capillaries to muscle cells and mitochondria. So that's what that connective part is there. Question 4. So a sedentary 16-year-old girl starts a 3K fun run as part of their charity day. Look at 4 acute responses her body would experience and explain how these responses happen. So anyone from the following list, so I would have said, again, 1 mark for having the acute response, and then the 2nd mark for being able to explain it. So increased heart rate, need more blood pumped around the body. Increased breathing rate, athlete needs more oxygen in the blood, so more breaths per minute. Decrease in the fuel stores, so the athlete will be utilising PC, glycogen and fat during this race. Increased perspiration, active thermoregulation to cool body. When people write increased sweat and increased redness and things like that, you need to use a specific terminology like I've used there. Increased stroke volume, so more blood per beat. So any one of those 4, but some of you might have had other answers that were good. Number 6. So we're looking at this graph. The following diagram shows the blood lactate curves of 2 athletes running until exhaustion. The triathlete and the well-trained club athlete. So they're starting to experience obla around this 5.5 meters per second, the club triathlete. Alright, you can see how, from here we start to have a steady incline. So about 5.5 meters per second. Some people said 6.5. That is wrong because you're measuring up here. That's when they stop exercising. Around here is when obla starts to occur. In his first race, a novice triathlete maintains a running speed of 5 meters per second. So the novice triathlete maintaining at 5 meters per second. We can see here the obla starts occurring for the novice triathlete at 4.5 meters per second. So explain the likely consequences of running the speed. So I've written they would experience obla as it is indicated in the graph that a novice starts to experience oblas of around 4.5 meters per second. At 5 meters per second, the athlete would experience extreme fatigue, which affect their performance. The athlete would not be able to sustain speed over 4.3. There we go, 4.3, without becoming severely fatigued. And the last question here asks, on the diagram, draw the lactate curve that you expect to see with a elite triathlete. So most people got that right, and that was sort of just showing that would go up there. A couple of people extended that up here. The elite athlete won't experience that sort of lactate. So you're just looking at sort of something like that. We can see that it's significantly under the novice triathlete, just as a natural progression. All right, so 3 students wanted to improve their performance in the beep test. They all participated in a 3-month extensive training program. The extensive training program would have led to many chronic training effects. So we've got to choose one of these physiological factors and explain how that would improve the student's performance in the beep test after this extensive training program. Data may be used. So I know Mackenzie did a really good answer, and he used levels from the beep test. That's really good as well. So those are the things that are going to get you that 5 marks. So I've put a couple of things here. So I've looked at AVO2 difference. So I'm saying it's improved as there's more oxygen being delivered to the muscle cells, equals more aerobic respiration. From here, this has happened through higher levels of hemoglobin and myoglobin. So what I'm saying is AVO2 difference would have improved because more oxygen is being delivered, and then more oxygen is being delivered because we've got higher levels of hemoglobin in the red blood cells and more levels of myoglobin at the muscle cells. Now, because of that, then improved performance, the athlete can run at a high aerobic intensity for longer. This may mean higher speed. Therefore, the athlete might get to level 12 instead of level 10. In relation to performance, all of these aerobic threshold, anaerobic threshold, AVO2 difference, and cardiac output all have to do with the fact that we are going to be able to work at that high aerobic intensity for longer, and then that's the data you could have used. So in terms of the last 2 marks, very similar. In terms of the first 3 marks, it was about understanding what that is, so understanding what cardiac output is. So cardiac output being more blood is being delivered around the body. And then you could say more blood is being delivered around the body because there's more muscular hypertrophy in the cardiac muscle, therefore a higher stroke volume, therefore our cardiac output is greater, therefore we're getting more oxygen to that muscle cell, more aerobic respiration. Same with the anaerobic threshold. Why is the anaerobic threshold being pushed up? Because of these reasons. All right. So if you're struggling with that, make sure you dot point it out. Because if you dot point it out, at least I can see the progression of your answer. A lot of you were just writing out the question again and then giving a 1 or 2 mark answer. So make sure, if you're unsure, dot point out specifics. Part 2. Describe 2 effects that extensive training program would have on the student's skeletal muscle, and I explain how that would have led to an improved student's performance in the beep test. All right, so let's have a look. So higher levels of mitochondria in the muscle. So even though we're improving our muscular hypertrophy, we're getting higher levels of mitochondria, which means we'll have higher rates of aerobic respiration, higher intensity at aerobic work. Something like higher glycogen storage. So again, we can work at a higher intensity for longer at the back end of the test. Higher PC capacity means the athlete could get an extra level at the end of the test when sprinting is required. But anything that relates to the test. So you needed to be able to give that example and then relate it to the test. All right. Research has found that aerobic performance at the time leading to competition can be improved by making nutritional changes, such as the addition to beetroot juice to the diet. So it gives an example here of a graph. Simply, it shows this VO2 changes. So, give the specific figures here, and we can see that here. Beetroot juice added to the diet and beetroot juice not added to the diet, we can see there's that there's a 0.1 change. So that's before we even ask the question. So, first question. Using data in the graph above. Lots of people lost half a mark. Using data in the graph above, state how the oxygen uptake of the cyclist who added beetroot juice to her diet is different from the... So, VO2 was 3.0 litres per minute compared to 3.9 litres per minute. Easy mark. Just need to pull the information off the graph. Alright, let's explain how the increase in number of mitochondria would lead to increase in VO2 max. So, more mitochondria equals more capacity for high amounts of aerobic respiration. All right, that's the be all and end all. Not more mitochondria does not mean more oxygen traveling around the body. Like I said in class, mitochondria is like where that your house is. If you're receiving mail, mail gets delivered through all the different passages, gets to your house. Mitochondria is at the muscle cell. That's where aerobic respiration happens. Doesn't have anything to do with increased hemoglobin, anything like that. Just mitochondria at the muscle cell. If we have more mitochondria, we've got more aerobic respiration. So if there's high amounts of oxygen available, then the athlete can utilize more oxygen for energy production at a higher intensity, which means less fatigue. So if we're having more oxygen being used at the muscle cell, that means there is an increase in VO2 max. There's VO2 max being the highest level that we're using oxygen as a source of energy. So in terms of performance, higher aerobic intensity means that the athlete can work at a greater speed for longer, equals better performance. Okay, D, identify the likely effect that a change in oxygen uptake at submaximal levels would have on a cyclist performing a 10-kilometre time trial. So, does the heart rate change at submaximal levels? Not really. However, the speed and intensity that you can work at submaximal levels increases. So what they're saying is if we get more oxygen in at submaximal levels, we can perform at a greater aerobic intensity, so a greater without using our anaerobic systems. So the change in O2 uptake equals increase in oxygen delivery due to more capillaries at alveoli and at muscle. Increased hemoglobin and myoglobin numbers equals a greater rate of aerobic respiration. All right. So in terms of performance then, more oxygen uptake means a greater submaximal performance. We'll complete the 10-kilometre time trial in a faster time. All right, another graph question, looking at untrained student preparing for a 12-kilometre fun run by undertaking an extended aerobic training program. So this shows two graphs, and we can see here the heart rate versus the oxygen consumption. So we can see graph X, we're only up to about 32 mils per kilo per minute before we get up towards the maximum heart rate. Where graph Y, we can see it's a slow and steady period up until that 40 mils per kilo per minute before we sort of max out. So for each graph, identify the student's heart rate when the oxygen consumption is 28 mils. So we just have to go up here, straight up, across, and straight up, and across. So I've written approximately 165 BPM for graph Y and approximately 135. And again, if it was within that 5, then I gave it. A couple of people was quite out, so you didn't get the mark. And graph Y is post-training heart rate. Because of that reason, we can see that we're going out instead of maxing out at around there. All right, identify two acute responses. Another easy one, and lots of people lost marks because they just didn't put increased or decreased. They just wrote breathing rate or blood distribution. You need to write if it's increased or decreased. You can't assume that I know. So any of those there would have been fine. All right, last page. So extended training program likely to produce chronic adaptations. Just like before, just like that question that we had earlier. Again, this is another one from another exam, so it's a frequent type question. So looking at how each would help produce chronic adaptations in the cardiovascular or muscular system. So let's look. Increased stroke volume. All right. So how would that help produce chronic adaptations? So more blood pump per beat, less stress on heart muscle, particularly at rest, lower blood pressure at rest, more oxygenated blood getting to the muscles, therefore a higher VO2 max. All those sorts of things. Increased number of mitochondria. You could have looked at more oxygen can be used as a fuel source, greater amounts of aerobic respiration, can work at a higher level of intensity, so therefore greater VO2 max, all those sorts of things. Increased use of muscle triglycerides, which means with greater glycogen sparing, work more efficiently aerobically without fatigue, higher VO2 max, all those sorts of things. All right. So there's some points that might have helped you there with your answer. Okay. Just to finish off, make sure you make the appropriate changes and learn from the feedback provided. If you would like further feedback, please pop in and come and see me next week, particularly Wednesday. I've got lots of time off on Wednesday, but make sure that you're learning from the feedback provided. And again, why I didn't put marks on them, why I didn't put a grade on them, because individually, you can't compare yourself to other people. Individually, you know how you prepared, you know your results and that reflection to your knowledge, and only you can fix that. So again, make sure you come and see me if you have any further questions.